Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 7th grade topic, Introduction to Factorials. Now, if you're new to my channel, I will put timecodes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today, or even your own homework, you can always put it in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 7th grade playlist in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video will have 3 parts, so leave a like, smash the subscribe, and let's get started! In math, we use a lot of shorthand, and that's because it saves us a lot of time. Instead of writing long drawn-out expressions, we have shorthands that give us the same exact meaning at a fraction of the space. And 2 of the most popular shorthands that we use pretty much almost all the time is going to be your multiplication and your exponents. So your multiplication, which is either that x or a dot, or your exponent, so some number raised to the exponent. These 2 things are our most popular, in my personal opinion, shorthands. Now at this point in time, we know that multiplication is going to be the shorthand of what? Addition. So instead of doing 5 plus 5 plus 5 plus ... plus 5, let's say 100 times, we can simply say 5 times 100, or 5.100. And this is our shorthand. So instead of wasting all that space, this is what we do, and we know it means the same exact thing. Likewise, exponents will work in the same fashion. Instead of doing something like 5 times 5 times 5 times all these 5s 100 times, we can simply say 5 to the 100th power. And we know that this means the same thing as this, except it takes up a lot less space. So shorthands are very popular in math, and factorials are going to be another type of shorthand. So what is a factorial? Well, a factorial is just going to be the shorthand we use for multiplying all, make sure it's all, consecutive positive integers starting from 1 up into a certain number. So I'll say that again. Your factorial is going to be the shorthand we use when you're multiplying all positive consecutive integers starting at 1 going to a certain number. So let's say you want to go all the way up to 4, and that's starting at 1 times 2 times 3 times 4. And you can do it the dots too. It's fine to do it the dots. It's just another way of denoting the same multiplication. And this is going to be 4 factorial. Now 4 factorial, or any factorial, is going to be denoted by that last highest number followed by an exclamation mark. And you can do the same thing for any of these such numbers. So let's say you want to go all the way up to 7. So starting at 1 times 2 times 3 times 4 times 5 times 6 times 7. And that's going to be 7 factorial. Whatever that largest number that you stop at, that's the factorial you have. So if I was to say, what is 3 factorial? What does that mean? Well, you should be able to tell me that's 1 times 2 times 3. Now you may see this in a different order. You may see it something like this: 3 times 2 times 1. And that's perfectly fine. We know that multiplication can be moved around and it's not going to change anything. So whether it's 1 times 2 times 3 or 3 times 2 times 1, it's the same thing. Now we also know that you can technically do something like this: 3 times 1 times 2, but you're really just trying to make yourself more confused. Keeping it in order is a good way, at a visual point of view, to tell if it's a factorial or not. Because remember, it has to be all positive integers starting at 1 up into your number. So if any one of your numbers is missing, you don't have that factorial anymore. So if you put it out of order, it's going to be a little harder to tell if something is missing. Now you may be wondering, do factorials have any other uses besides simply being a shorthand? And the answer is going to be yes, especially in the permutation field. If you have a certain number of objects and you want to know how many different ways you can arrange those objects, Factorials will give you that answer. So let's say you had 10 different objects that you needed to arrange, and you wanted to know how many different ways you could possibly arrange them. Well, simply doing 10 factorial will tell you all the ways you can possibly arrange those objects. So let's look at a quick example in which we can see that in action. Let's say we have 2 objects, and the object is going to be a gold coin and we have a white die. We have 2 objects here, so we want to know how many different ways we can arrange these 2 objects. Well, we just said that if you're trying to figure out how many different ways, make sure it's different ways, you can arrange these 2 objects, all you have to do is how many objects you have? Factorial. And we know that 2 factorial is going to be 1 times 2. So how many different ways can you arrange 2 objects? Well, that's just going to be 2 different ways. And you can tell, if you have 2 objects, all you can do is something like this. There's no other way of arranging these 2 objects. So let's say we have one more object. So instead of having just 2 objects, we have 3 objects, and we want to know how many different ways we can arrange these 3 objects. Well, once again, you're going to be doing the amount of objects you have, factorial. And we know that that is going to be what? 3 times 2 times 1. And what's 3 times 2 times 1? Well, this is 6. So this means that we have 6 possible ways we can arrange 3 objects. Let's see if our math pans out. So if we had 3 objects that we wanted to arrange, and we want to know how many different ways we can arrange them, well, our math said it should be 6. And if we actually try to arrange them, these are going to be the 6 different ways. There's no other way we can arrange this than what's listed here. So it seems like our math pans out, and you can look at this with higher examples if you have all the pieces necessary. So just know that our factorials have a use other than simply being a shorthand, and that is in the permutation field. It can tell you how many different ways you can arrange a certain amount of objects if you know how many objects you have. So I would like to finish off this video with some special factorials. Now these factorials kind of don't make sense when you look at them from a mathematical point of view at this point in time. However, you need to commit these to memory, and you're going to just have to trust me on this one. So the 2 special factorials that we're going to cover are just going to be 0 factorial and 1 factorial. These 2 are what we call special factorials. And because of how we defined our factorials, this is going to be very weird what I'm about to do next. 0 factorial is going to equal 1. And 1 factorial is going to equal 1. Now that might have just blown your mind. How is 0 factorial equal to 1? When we're multiplying anything by 0, we're going to get 0, right? As a matter of fact, the definition of factorial means that you have to start at 1, right? We just said that, and 0 is definitely not starting at 1. So how is 0 factorial 1? And you might be saying something similar here. How is 1 factorial 1? You're not having anything consecutive, you just have 1. So let's think about it in a less mathematical sense and a more physical sense. We just talked about how factorials can tell you how you can arrange different objects, right? Well, think about it from that point of view, and this makes a little bit more sense. If you have 0 objects, how many different ways can you arrange 0 objects? Just the 1. It's nothing. This is it. If you have 0 objects on my whiteboard, there's only one way to arrange that, and it's just 1. The same can be true if you had 1 item on my whiteboard. If you just had this 1 item, how many different ways can you arrange this 1 item with itself? 1. These 2 special factorials make a bit more sense. However, if it still doesn't make any sense to you, just know that 0 factorial is 1 and 1 factorial is 1, and try to commit that to memory. So I hope you're able to follow along with today's examples, and I hope you now know what a factorial is. However, if you have any questions about what you saw today, or even your own homework, remember you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave a like. It really helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.